If you can, yeah, super. Welcome again for recording sake. I was talking about that Diki you might have, really we
Yeah,
haven't heard. Can you share how your son doing and what's going on in their world?
yeah. I mean, he is now almost working in. He graduated from Carnegie Mellon in computer science and joined Google.
Hmm.
He's working in Manhattan. Initially, he was on a rotation program. Now he's in BART team, which is now I think rebranded as Gemini. Right? It
Correct.
is. It's a competing product to the Chat GPT or whatever. Right? So he's on the team. Yeah, I think his role is mostly integrating the backend with different and Google applications like
Mhm.
they have Google Docs and Google lot of Google applications, right? Their
Mhm.
calendars and all that. So he's in that team of integrating the backend with all their Google applications. He's enjoying. He's liking his work.
Super. In
Um,
Carnegie Mellon, he also done ML, right? CS plus
yeah,
with ML, AI, right?
yeah. He did ML as a minor. So that's one thing he did, and I mean he has a good friends, right? So most of them are in New York now. So he's enjoying his work as well as the whole friend circle and everything. He's doing good, Vemla. Thank you,
Super DK
Srini.
and everyone. We will also brush up a lot of AI basics. Uh,
Mm-hmm.
Probably, who knows? We may be working with your son or some new graduates.
Yeah.
Super. Awesome. Amulya, go ahead. Amulya, you're on mute. You can go ahead.
Yes, Sri. Um, Thank you. Oh,
You can speak about yourself and all are wonderful, nice, friendly people. So welcome to our gang, Amulya.
Thank you, Sri.
Yeah, welcome,
So, hello,
Amulya.
everyone. Good morning.
Yeah, good morning. Go ahead.
Harun, if you want to go ahead, you can.
No, go ahead.
No,
Yeah,
you can
you can
present your
introduce
topic.
yourself and then you can present your topic. Yeah.
Present your topic. Yeah.
Oh, sure. Thank you. To begin with, I would like to thank Srini and Harun for giving me this opportunity. So, I'm an experienced data engineer with over 7 years. So, throughout my career, I have worked in multiple domains like Anthem, the financial domain, banking domains like Truist Bank, Citibank, and even I have worked in telecommunications domain, Verizon. And currently it's the healthcare domain, CVS. So I do know about like multiple challenges and how to deal with data, where when we get large data sets. So I'm specialized in building and optimizing data pipelines and architectures on both AWS and GCP platforms. So my expertise extensively includes with big data technologies like Apache Spark and Hadoop tech stack. So I'm passionate about continuous learning and staying ahead of emerging technologies to provide innovative solutions. I just want to share my screen for today's
What are
presentation.
the new things you are learning, Amulya? Are you learning Databricks or?
Yes, Shini. I started learning from the day I have you have shared me about how Databricks works. So I'm preparing for the certification initially for the Databricks Associate, and I think it must be easy for me because I'm good with Spark.
Super, super. Yeah.
So let me quickly share my screen. Um, I'm sorry, I'm having trouble.
And please see if she can share that share access option.
Yeah, I'm checking 1 second.
I think
Yeah,
the
can you
sharing option
check
is
now?
there.
Yeah. Amulya, you're
Okay.
good to go.
Yes, I'm good to go. I do see it. Okay. Okay. So today I'm going to explain about the data engineer use case. And these are my contents. I'm going to explain about what tech stack a data engineer requires in the present emerging technologies world. And it's all about, when I explain my architecture, you must be aware of what tools exactly I'm using, and just to be aware, and a little bit of PySpark code logic, which I have implemented. As you all learning Spark, you must be aware of most of the code snippet while I am explaining, and what issues I have faced with large data sets and how I have overcome it. So to get started, data engineer tech stack. So the first thing is you must be aware of one Apache Spark programming language with any high-level language. For example, Python, Scala, Java, or R. Most of the companies use Python and Scala in current, but then Java, I have seen it in Citibank. A couple of banking domains utilize it more. When you utilize Scala with Spark, it's a little bit faster, but it doesn't support the machine learning, and I mean, the Python has the inbuilt libraries, so that's where everyone going with PySpark. And you must be aware of a shell scripting commands, because most of the time we'll be writing shell scripting to include our code. And next is one Hadoop framework, the platform. You must be aware of either Databricks, Cloudera, it's not used anymore, and Hortonworks. Cloudera was open source, and even Hortonworks as well, but it's not as proficient as Databricks, because Databricks is developed by Apache Spark company itself, and they have more emerging tech stack. They are in building with Databricks, and they are making it more robust. Um, and you must be aware of these Hadoop tools: MapReduce, Hive, Scoop. Scoop is for ingesting data from multiple data sources to Hive. I think you must be having a alternative in Databricks. And DistCP, you must be aware of it, where you can transfer data from one cluster to other. You'll be using DistCP commands. And you must be aware of this SQL, the RDBMS, Oracle, MySQL, Teradata, SQL Server, which process this structured data, which store the structured data, not the process. And you must be aware of one NoSQL databases. And so the others would be similar. So you so right now everyone are using either AWS, Azure, or Google for the storage. And why they are going with cloud is the traditional storage is much higher and expensive. So the clouds provide the I would say the cheapest option. More than cheapest, I can say it's uh, they don't pay extra for what they are utilizing for storage or processing, and the ETL pipeline building tools. So these are the pipeline building tools, which are more famous in recent days. It's the data stage and InfoWorks. InfoWorks is something where it really helps with connecting to the data sources. It's just a few clicks away. You can connect to the data source and you can apply the transformations on top of it, and you can load the data, like ingest the data into the target from source to end. It's the end-to-end pipeline building tools, the data stage and InfoWorks. And you must be aware of these schedulers. So these schedulers, you need not manually run your job. So you can just schedule them for which time you have to execute. So when you schedule it, it does the job. So Oozie is more a kind of scripting way. I would say it's more about coding, but then ESP, Tidal, I think they are just like a Windows laptop where it's more about the graphical user interface rather than coding, and control them as well. And Airflow, it's mostly used for cloud. You can use so that's about the DAG schedulers. And crontab is something which the companies used to use, but they stopped using it because it's not that easy to use crontab. It's more confusing when you have more number of jobs. And streaming tools like Kafka and NiFi. Some say it's Nifi, but some say NiFi. So these are the streaming tools, like the trending streaming tools which the companies utilize. I have worked in multiple architectures, but then I'm going to explain the recent one. It's the ETL architecture for batch data. So when I say batch data, it's the historical data. So we have two types of data: streaming data and batch data. When I say streaming data, it does not perform the real-time streaming. It's near real-time streaming. So it's all about the real-time streaming is not achieved yet. If it's achieved, then a lot of new, what do we say, new inventions would happen. So to get started with, as I said, we'll be connecting with multiple data sources. When we say it's an end-to-end pipeline, we'll be connecting with the any source systems where we could get the data, and we will be having a target where we'll be storing the data by processing the data in a more meaningful way. So that's how the big data emerged. So even we ingest the files as well, we have a specific folders which the users get registered. The source team will get registered, and they will be having access to that folder. So they'll be pushing the data to that particular folder. So when I say source team, it would be any application teams. And these are the RDBMS, so where we connect to. So our Spark code will be having connections with whenever we want to ingest data. When the script gets triggered, the connection is made first, and then Hive is utilized as staging. So in companies, they use staging to avoid any critical data loss in the target. So first they load it in the staging area. If the data is perfect, like if it has no issues, then they load it into the end, the target. As I said, Hortonworks is an alternative platform for Databricks, but then everyone is migrating from Hortonworks to Databricks and the other. I wanted to say this. So this is a migration project where we are moving all the jobs from Hortonworks to Google Cloud Platform. And but at the time the data gets into the staging, we apply the transformations. You must be aware of the transformations and actions which we perform in Spark. And even we ingest the files, and from files, you must be aware of these external tables. So we'll be processing the data and storing it into a particular folder locations where we'll be loading the data to Hive tables. And from there, the staging will, once the transformations are applied, we'll be loading the data to our target. So this is how the end-to-end pipeline, the ETL framework goes. Extract, transform, and load. And in the current company, I'm using BigQuery. So BigQuery is that efficient, it could process petabytes of data. And it from here, we will be making sure that we load into particular tables where the machine learning teams and users have access to. And if there is any issue with the data, they respond to us back, and we'll be helping them if they have any duplicates or any other issues. And so as said about the schedulers, we utilize a tidal scheduler where it helps us to make sure that the jobs are scheduled perfectly, and the end-to-end pipeline, the data is ingested into BigQuery. And in addition to that, we keep on adding, creating new jobs for the new tables. And one more thing I wanted to add here is a couple of tables will be having more than 100 gigabytes of data. So ingesting them every day would be a hectic. So that's the reason what we do is we ingest the data incrementally as a day wise. So once we load the historical data once, we'll be loading the data day wise to the BigQuery to make sure that the other critical data, or if to avoid any issues with data or long time for processing. And this is a code snippet that I wanted to explain. So this is just a part of it. And you must be aware of this Spark session where we have these data frames. To create data frames, we will be using the Spark sessions. And in companies, we don't hard code the values. Instead, we pass them in a runtime. We'll be adding these values into a file and then pass them to the code. So you could see all the values, and we'll be utilizing it and ingesting it to the target table. The target table name, you could see the values are appended, and then it will insert the data into that particular table. You all know about this coalesce. So this coalesce is something where it reduces the number of partitions. So I have given the mappers. So mappers takes the argument. If I give 1, it creates one output file. So it's all about reducing the number of partitions. And okay, this is the other thing where we help the machine learning teams. So this is how about we pick up the top 3 vaccinations as it's a healthcare domain. This is more about uh, uh, our team is more involving in AI. So that's where we had a chance, we had a opportunity, I would say, to make sure that see how the data works, how we have to implement the logic. It's about removing the duplicates, cleaning up the data, how we require for mesh analytics, how to display it. So this is a part of it where we will be picking up top three vaccinations, which and then we will be using multiple joint conditions on top of the 3 with other tables. So to explain about this logic, it's here where we are creating 2 RDDs, vaccine file and claim file, where we'll be loading a data, and then we'll be using the reduce by key, where we are doing the data processing, and then we are utilizing this sort by key, ascending equals to false. So it sorts the data into a descending order and then picks up the top 3. And once it's done, it writes the file. So it writes as a text file because it's just three records. Okay. I forgot to mention here. Here we are utilizing the ORC format. Why do we utilize ORC and Parquet? Because ORC and Parquet file formats are mainly used for large data sets. So this is where, it helps you to process large data sets efficiently if you utilize ORC and Parquet format. And this is all about how you save the Parquet files. As I have already mentioned, the coils, I'm sorry, coils and what, how you save the file into a cloud storage bucket. This one I have given a sample one. It's not the main one, but then so this is how you will be saving a Parquet file into a Google Cloud storage, and then you will be utilizing the multiple transformations on top of it, and making sure you will be creating a temporary view name, and then you are performing this Spark SQL command, and then you are saving it. So when you save it into less number of partitions, so that's where you are reducing the number of shuffles. The other way is repartitioning. So repartitioning is something where it distributes the number of, it increases the number of partitions to multiple data nodes. So it has to be utilized in a different scenario. And this is where coils is used for mostly saving the files. So I'll be quickly wrapping up. So this is how we will be facing the issues with the large data sets, and these are a couple of solutions which we have used in our teams. So data partitioning, we'll be making sure that we will be repartitioning the data and calls according to what required, and we will be even using the caching and persistent storage. So cache is something where the in-memory processing of the data, so that helps in boosting the job runs faster. It's a kind of RAM memory when I say cache. And memory management will be giving the executor memory according to the data sets, the data size at the runtime. We can increase the executor memory and the broadcast variables, you must be aware of it, where we will be distributing the read-only data to multiple data nodes, where it helps to reduce the number of IO operations. So that's where it helps in processing the data much faster. And to avoid shuffling, we will be making sure that we use the broadcast joins and making sure that we use a less number of reduce operations. And this is how we operate. And thank you. I'm good for taking up any Q&A.
Yeah, awesome, Amulya. Thank you so much. This is very good, awesome presentation. Guys, please appreciate Amulya comments. I will open up, I'll add some context to this. Maybe we'll discuss for about 10 minutes. And then we can also go back and ask questions. But before that, please go ahead and, how what Amulya did. Please comment.
Yeah,
feedback,
Amulya, it
appreciate.
is very nice presentation, and especially the slides you made, at least to show the picture of how any data project will run, at least the high level. Thank you.
Thank you, Nag.
Yeah, Amulya did a good job. Like, yeah, you went through all the process and all. Yeah, I like that. Good job.
Yeah, thank you, Prasanna.
Any questions? Any questions or comments?
Yeah, I got to know new features in her demo. So very nice. So more interesting to learn those things.
Yeah, really nice presentation, Amulya.
Yeah.
I think we also followed the same earlier when we migrated to Databricks. But we were using Java code to process the data, to transform the data, that's really good.
Yeah, DK, any
Yes,
comments?
Yeah, it's very good, actually. It's a life cycle of a data, right? From ingestion all the way into reporting. So it's you extract, transform, load, and in Databricks, lot of she explained in the Hadoop tech stack, but I think it's much simpler now with Databricks, right? A lot of those
Right, exactly.
optimizations
Yes.
and all those things that we used to code, do it in the Hadoop data stack is much simplified in Databricks. So the job for a data engineer is much easier now if we know the concepts. That's what I felt.
No, good point, DK. Especially
Yeah, and
do not know.
Amulya,
Go ahead, Nag.
while you're mentioning, you're little bit confused on cron tab. Cron tab is a Unix and Linux standard feature. It is not something that we can program. That's why it is complicated, because all command line. Just want to let you know. So in future, you can specifically say that it is a Linux default feature, but it doesn't have any GUI or anything. So that way you can explain better on that.
It is a raw way of, it's still a scheduler, right? Not,
Yeah.
Yeah,
so
it is a
still
scheduler,
still
but
a
there is no
scheduler.
like user-friendly tools.
Yeah.
Sure,
It's not user friendly, but it's
Yeah.
still, that's how we used to do long time back to schedule jobs. But yeah.
But have you found this? Have you caught this? Under the hood, your systems, again, OS level, it's a cron only. Even though we schedule it through Airflow or even workflows, you have UI, but those are ultimately transmitted. Ultimately, these VMs are all running on Unix, right? Correct? Nag?
Yeah, underneath,
That's true.
probably
Yeah,
you're
that's
right.
true.
Underneath.
Yeah, that's true.
Yeah.
underneath. That's why in the workflows, if you go to Databricks workflows, it shows even the cron, how it looks like a cron. But anyway, that's a good point, Nag.
Yeah.
DK, what you highlighted is also very, very important point.
Sorry, Srini. I used to use cron tab initially in my initial process, but since then I haven't used anywhere.
That's what they are saying,
Yeah,
you know,
that's fine.
since it doesn't have UA. But DK highlighted a very good point. Now you all know why Databricks is growing. It is how much complicated it is to do the outside
Yeah.
Databricks. So many
Yeah.
technologies, so many tools, so many things. In fact, Databricks is even to reduce the code. You don't have to stop you don't have to create the Spark context. You don't have to stop the Spark.
Exactly.
So
So,
all
yeah,
of
Amulya,
go ahead.
Yeah.
Correct.
Yeah. So Amulya, can you go back and share your slide? I just wanted to add few comments for the sake of this team. So what you have done is amazing job. Okay. Yeah. So if you go to the last, let's come back from the last slide, right? Yeah. So here, so these are all what we are doing. So team, I just want to relate what we have done in the training, right? So just check. This is the actual industry use case that is running for people who are new to Databricks ecosystem here. I want to just reiterate that whatever we have practiced, we have done in the training is all part of what is the actual use case that we are doing in the industry as well. Like repartition, coalesce that we learned, cache, persist that we have done. So broadcast. So we did broadcast join. So variables also can be broadcasted. Reduce by and join optimizations that we looked at join strategies and how we join different tables. So reduce by key is a transformation that we have done using group by aggregations. And then we kind of see how we avoid shuffles. How does the shuffle impact the how does the joins impact the shuffling of data, and it will impact the performance and all of that. Right. So if you just go one level up slide, Amulya. Yeah. So if you look at here, right, so just look at SQL contest.sql sc.text file. So all of this is the raw PySpark code without the Databricks. That's what DK was also highlighting, that when we use Databricks ecosystem and notebooks, all of this is by default given to you. You just use the widget. Yeah. Sahil, can you just yeah. So then just use the cell code using %SQL, and then you can just write your SQL, which is what is here, like SQL context.SQL. This is the old way of using just the Spark without Databricks and notebook environment, Databricks environment. And then you write the SQL. So what we are doing here, if you see, is you are extracting information from the existing data like patient ID, claim amount, and all of this information. And then you are writing. This is what we did when we did write the final data into the gold layer aggregations. I think somewhere we also have some aggregations in this, but you can see register temp table that we also did, register as view and then use it in the SQL to do SQL on that. And then map is here basically the same transformations. So if you see here, medication file dot map lambda L split by pipe, right? So that is the same transformation we also used when we did our transformations on the data frames. Remember, you take a string and then you split that into multiple columns. You can do with column, you can add and then give expression how you want to populate that column. So all of this is actually we have practiced using the medallion architecture, and we read and write using the same transformations that we did. And coalesce here, we also did repartition and coalesce. We practiced all of this, right? So the difference here is instead of using sc.text file, we directly read using spark.read and the file format, all of that. and by default it writes Parquet format, and we have also seen read the CSV and JSON files, and here you're reading the text file. So it's all same thing. 80 to 90%, 80%, at least 70 to 80% of things that we actually do at the workplace is what we have practiced in our training in the last few weeks. That's what I wanted to reiterate and relate to an actual use case that Amulya has shared with us using PySpark.
That's a good call out, Harun. We did not know what Amulya was presenting.
Right.
In fact, that's great how you relate what we are doing in Databricks. And good points, DK, how Databricks is simplifying why people are migrating, because they don't want to spend so much time and energy on the technical. More value can be added if you can bring this data to the users very quickly. That's why everything, what you just need is Databricks. That's it. Everything will be taken care. A lot of even scheduling parts. Of course, Spark is created by Databricks team originally. They open source to see the beauty. Every company, whether they use Databricks or not, they are using Spark. They are using Spark. So that is a beauty. That's why the migrations also is not difficult, because the code is, at least, even though the tools are different, at least the code is related to Spark. Just you will have to do some cleanup, which in fact, which is easier on Databricks. So great job, Amulya. What you have shared really helped them to do any migration project. If they go to a migration project, there will be a Databricks, there will be a Hadoop or non-Databricks systems. So there will be that legacy team. We call it as a legacy team because that is the current system. The future system is Databricks. You are a Databricks consultant. You'll be working with them hand in hand. So you will be showing Databricks features. They will be showing what they have done, and there is a collaboration. And initially, there is a 50% overlap in the language. Slowly, you'll understand what they are doing. They will understand what you are doing. Ultimately, you'll be doing a project. Great job, Amulya. What you have shared. Excellent.
Yeah,
Any
good job, Amulya.
quick comments, Shiva and Chandra? Any quick comments or questions to Amulya? Yeah, Purnima, you are silent. Any comments or questions to Amulya?
No, this is great. Yeah, I was just wondering about the same things on why we use Airflow versus we already have the same feature in Databricks workflow and yeah, Spark context, all that. It's good. Harun explained it well after Amulya, but it's great to know how they used to do it in the Hadoop world versus now how easy it is to configure using Databricks.
Oh, super, super, super. That is what is, when you don't know the difficult things, you need contrast, especially there is a difficult way of doing it. Now, easy way of doing it. You really appreciate Databricks more if you are already worked in a legacy projects. DK has seen this type of projects, he has been seeing last 1 decade. Sahil was involved in it. But good, Amulya, appreciate you bringing this use case and sharing it. You presented so well. Excellent.
Yeah, appreciate it, Amulya. One more thing I wanted to talk about was in the snippet that Amulya shared, we had like top 3 vaccinations that they are aggregating and showing in. So that's what we also like. For any data set, for any project, the first thing we ask about is what problem we are solving or what analytics that we are providing. So right now, what Amulya has shown is like top 3 vaccinations they wanted to see. So that's the problem statement. Now we walk back through it. So then there is a raw layer. We take the data. Then we do in the silver layer, we do all the transformations, get the data, write it to silver table, and then we do aggregation, like give the top 3 vaccinations from this. That is exactly what Amulya has showcased in the code snippet.
It's a good point.
Yeah.
A good point, Harun. So what Harun is encouraging is everyone focus on the solving the business problem. Focus when you are doing it, what it is empowering, what use cases it is solving. Prasanna Gattamaneni, Kishore, could you please relate to what you are learning to what Amulya shared? Any questions and comments to Amulya? Prasanna and Kishore.
Great session, Amulya. Okay, it gives us a great insight, okay, about how you migrate from the legacy. Now you are using Hortonworks to Google Cloud, or maybe in future it may be Databricks, right? So it gives us a great insight, and overall architecture also she has explained, so that that helped us understand very clearly, actually.
Super. Prasanna, any comments, questions?
It really was a great presentation, Amulya. So in the first slide, you mentioned like what are the data tech stacks which you are going to utilize, and that really helps a lot, actually.
Super. Now, having seen this, I think you'll be very happy to be in Databricks, right? You don't need to do Scoop, you don't need to do Pig. You don't, of course, MySQL, Teradata, there are only source systems, ingestions. You can relate a lot of things. You see here, Apache Spark, you are using it for computing. You don't have to worry about Java, R, or Scala. 90% people are using PySpark. Shell scripting, basic Unix commands already list and DB utils fs. It helps always. You cannot escape from Unix. If not scripting, at least basic Unix commands. Please brush up. Cloudera, Hortonworks, they're all going away. It's all Databricks or cloud systems. Hadoop tools, of course, the tools, even Databricks is not using for your MapReduce and all, is a code without Spark and Hive, HQL. Now everything is through SQL, ANSI SQL. Your ANSI SQL runs in, of course, Hive is there. Hive is still there. We have Hive Metastore and Unity Catalog. Both exist. So Pig HDFS, dist copy is another command on the clouds people use related to what you called Unix. It does, in fact, if you do clone, you remember what is that? Clone, not clone. Shallow.
Deep clone, shallow clone.
Deep clone, shallow clone. They all use the zero copy mechanism without using a lot of I/O. So it's a low-level TCP/IP level copying of data. And SQL, Oracle Server, they all be either source or targets where you can write to them. They're always there. Teradata, people are migrating from Teradata to Databricks because Teradata is not scaling. But you will be working with Teradata teams. You don't have to know anything about Teradata. NoSQL databases, DynamoDB, MongoDB, they can be Apache Cassandra, they can be source systems or target systems. So in Databricks, you can able to read from MongoDB's Apache Cassandra, or you can write to them. So, but under the hood, it is so not under the hood, it is centralized Databricks. So you can be able to work with those teams. Not every company may have this, but some companies may have it. Cloud storage, you'll be working one of the cloud at your company, or sometimes two clouds. Usually AWS and Azure are famous. Google is also picking up now. But again, the same, your Databricks on AWS, Azure, Google, more or less the same. ETL's tools, for us, legacy, they use all those DataStage, InfoWorks, and Vision. For us, it is a Spark. So ETL, extract, read, and transform and load. So your ETL is nothing but your PySpark. Of course, Databricks also gives a Delta Live tables, which is even now getting simplified. Schedulers, your company may have Airflow, or they might use Databricks workflows. So Airflow is a third-party tool. In the big data world now, cloud area, people are not using Control-M or anything. People may use ADF also, Azure Data Factory. But again, all are same. They are just scheduling tools. So when this job should run, and this task should be depend on what task, can this task pass some variables to other task? Can it run nightly, different schedules? Under the hood, it captures those cron parameters and pass to those VMs where these jobs are getting run. Awesome. Streaming tools, NiFi, not many people are using. If you go to a company where they may have NiFi jobs, but they will be converting to either Kafka or what you call Event Hub, Azure Event Hub. So Kafka is more famous. But for you, there will be Kafka administrators. You'll be writing your streaming jobs to read the Kafka and to write the Kafka. But you are not the one who manages Kafka. You are not the one who is expected to know what is going on inside the Kafka. There will be Kafka team and there will be different team. Your job is fully a Databricks consultant. In the Databricks, you'll be writing ETL jobs, both batch and streaming. I think Harun did a very good job, and Amulya, this is a good presentation, seeing the contrast to connect to all the things. How does it sound, guys? How does it sound? Pawan, Kishore, Prasanna, Sahil, Nag, you feel good, right?
Yes, Srini.
Yeah,
Very good.
definitely, Srini.
And it is close, Sahil. We've done this, right? All the
Yes, we did the similar project to migration to Databricks.
That is very good.
That is where I want to really encourage you, all of us. It is the same. The architectures are the same. Only the tools are a little bit different. That's why these are all open architecture, right, DK? When we started our discussion also, even though we are learning from the Databricks side in a more simplified way, but the ingestion, transformation, streaming, batch, and writing to even you may be writing to Snowflake. So having that map, which Amulya has brought it very clearly. Amulya, can you quickly show that diagram once the ingestion source systems are there?
Yes,
ingestion source systems are there. Then the see the source systems, they exist in the on-prem or they may exist in the cloud. In fact, now there can be 100 ingestion systems, including Salesforce, etc. Earlier they are using Hortonworks systems. So again, Amulya also highlighted batch or streaming. Amulya, interestingly, our team learned streaming also. So they also migrated to cloud platform. So instead of HDFS, they'll be using BigQuery. So BigQuery is also a kind of Snowflake, but you'll be using Databricks, has both Delta Lake and data warehouse, which we call as a lakehouse. Right side is a UA layer, you see, where Databricks can be connected using Power BI, Tableau, etc., using some connectors. There will be data analyst team who will be doing it. But Databricks also have a way of doing some dashboards, not a full-fledged dashboards like Tableau and other things. But what I want to highlight is, as even Harun echoed, DK echoed, and all the team, if you see the pattern, the architectures are the same. Only tools are getting better. That is the reason maintaining all these things are difficult. They are standardizing into one lake house where you'll have a data lake and data warehouse. That's why Databricks is getting famous. I've been in Databricks 6 years. It's awesome. Customers appreciate, and it makes life easy, and it brings value to the customers. Great job, Amulya. Again,
Srini, I have a quick question here.
Please.
Do we have a user interface for the ingestion, like for the dimension tables or somewhere? If somebody wants to enter any client, new client or new product ID name, is there a UI that can be hooked up to Hive, HDFS or Hive, like to the catalog?
That is a good question. No, because these are OLAP systems. There is no transactions entering into it. But Databricks is going towards that probably by next year, especially some systems like MDM systems. When you open there should be human feedback. If you have two rows with two names, they want to take only one row. If you click a button, it will go and update. So right now the updates are only through batch jobs and streaming jobs. Only your program can do. There is no UI where you can go and update, and which updates a table. Those exist usually in the in the OLTP systems. In the OLAP systems generally won't take. But there are some use cases that are coming now which needed a UI, to take the data and go and update. But what the Databricks UI is only for the tools like workflows or creating scheduling jobs, like for operational UI is there, but not the transactional UI. But great question, Purnima. Does that answer your question, Purnima?
That answers. We have a use case where we usually enter all this information and it gets stored in the tables. But when we move to Databricks, I wonder how we are doing it. I'll find out and I'll let you know.
Okay. That's a good question. Last, before Harun take over, any other final comments or questions to Amulya? Anyone? Pawan or Prasanna? Sahil? If nothing is there, I will say this. Good job, Amulya.
Thanks, Srini. Thanks, Harun, for giving me this opportunity. And
Thanks,
I would like
Amulya.
to present more, even in further classes. Please involve me.
Super.
Yeah,
We'll invite
absolutely.
you and even
Definitely.
other people, Purnima, DK, and everyone has to present. We'll be taking some topic, whatever you have done previously, or even what you learned, or even I will give you some use cases with some helpful where you prepare and present. When you present it, you think, also you connect with people very well. I know you might have done a lot of presentation in your projects. That's not an issue, but only in new areas, we want to make sure you're also comfortable so that you won't sound as a student. Actually, we want you to try to sound as a professional who is doing this project already. In fact, I've seen the project where some of our students, I will not call them as students always, even if I had to that, even Harun learned from me. But again, when they go to projects, in fact, the project teams felt Arun is more knowledgeable than them, even though Arun was doing it first time. So that's how we do in the class. DK, you might have seen, we bring very practical insights because that's how our classes are different. That's why these are more a professional way of learning together. All of you feel you are collaborating, and we relate. We check with Sahil, hey, we done this project, how it is, etc. That is the phase we are going to get in now. We'll invite people like Amulya from outside, but you will be involved to present. That way, when you go to project, you feel very, very comfortable. How does it sound, guys? Purnima, does it sound good?
Sounds good, Srini. Thank you.
Super awesome. Again, great job, Amulya.
Great job. Thank you. Yeah.
Go ahead.
All right. Thank you so much, Amulya. So we'll get started. So I have Subbu. He just wanted to share for 10 minutes. And then after that, I will take over. We'll talk about some topics after that. Subbu, quickly for 10-15 minutes, you can share if you want to.
Yeah.
So as we all know, Subbu was also new to the Databricks ecosystem. So he started with us and, he's learning and he's booked his certification exam. So he's preparing for that. I would encourage team to help. He'll be reaching out, how to prepare. If there is any content or some dumps or record or videos that you have used for certification, please share. Already, I think some of them content is already shared in the group. I will encourage people to share and support each other. Yeah, go ahead, Subbu.
Yeah, so use case, I took data from Amazon product sale. So from there, category and subcategory and discount data I have to populate. So to the filter of ratings and discount. So this is my use case. So for that one, I have to use Databricks. Why Databricks? Why I'm using? There is a it has a medallion architecture. So medallion architecture is nothing but what is that? It describes the series of data layers, and it denotes a quality of data. So in which I import the data, means ingest the data into the branch, and from there I filter the data after this some transition. I filter data and into the silver, and from the silver to gold, then aggregate data will be populated. So that is the my scenario. For that one, first I imported the data. So what are the data I imported? I took it from the uh, Amazon. So I input in my local. So from my local, I input into the Databricks file path. This is the Databricks file path. The location is I provided as Amazon. So this is the default file path. So I gave the folder name is Amazon. Under Amazon, all these files uh, inserted. All these files are loaded. Okay, so once data files are inserted in the Databricks, so what is the next step? The next step is you have to create as per our as per I told you earlier. So bronze, silver, and gold. So as a three data layers, you have to three databases you have to create. So I created through catalog three databases, but yesterday what I did, I created one more compute. So because of that one, it is not showing the it is a list of databases here. Uh, but previously what I created, it is showing here. So three databases I created: bronze, silver, and gold. Uh, Next, so I started to import the data. Sorry. Yeah. So from here, so what are the files I imported? So into the DBFS is nothing but the database file path, and it stores under the file store. So I created the DB data frame branch. So what is the data frame? So data frame. Earlier it was the RDD data set and data frame. So RDD is a resilient distributed data set, and it is not it is a immutable data, so it can't be changed the data set, and it did not have any schema. Now all under RDD and data set under the data frame. So we have the only data frame. No need to go for data RDD and data set. So from there, I inserted I read the data in the data frame. The Spark. Spark is a library for the default programming library to read the data. And it's an option code, and to read the CSV file. So file path. So what are the file path I provided here? That is the file path, and the header is true is nothing but on top of the file. So header is providing, and infer schema. Infer schema is true if you specify infer schema is true is nothing but so whatever the data type is provided in the column, you have to take it. You have to input the file. So if you know, so we can define our customized data type from ourselves. then what are the data frame? So under the in this, I displayed here. Okay. Okay. Next. Mhm. So are you following what I'm? So is it speed or?
Yeah, so go ahead. Yeah, you can go ahead.
Okay.
That's
Okay.
good. Hitting good. Yeah.
Okay. These are the data frame files. Okay. Now, so what are the files I read in the data frame branch? So we can see the what are the columns under this data frame branch. So once the data frame branch columns, you see the data types. Now you have to define the data frame branch table name. So in the branch table name, so earlier you read the here you read Spark. Spark is nothing but read the read the file, but data frame branch dot means what are the read, you have to write it here in the format of delta. So in the format of delta mode means you know what is the delta. So delta is a
Yeah,
another format.
yeah, go ahead.
Yeah, delta is is one of the format. So like JSON and CSV and delta. So default it is it reads in the uh, delta format. So delta format, what it will do, whenever you input the data, it is in a Parquet file. So on top of that, the delta uh, uh, for create a wrapper. So on top of the wrapper, a delta, it will create the transaction logs, so which is newly created, which is updated, which is an old record, which is deleted. That transaction
to
log
give you the asset transactions. Yes. Yeah.
as a transaction. So,
insert update. Yes. Okay.
Yeah. So that is a data format.
By default, it is delta, right?
Yes. Yeah.
Yes.
Yeah, even if you don't write format delta, if you just write, it will be delta format by default. And the file is anyway Parquet.
You can choose there. What other formats you can choose there? Like JSON.
So if it is, if it is not, delta, then you can write it as the JSON file, or you can write it as CSV, Parquet, whatever you can write.
Why do you even want it to write? Because
I don't want to. Yes, but option is there. That's what I say. If you just want to write as a JSON, you can write or format JSON. It just writes the JSON file there.
Okay. Now the data is we are saving in this table. What we created previously in this table, we are saving the data. So whatever the data in the files that we are ingest here in branch. Okay. Now, so the say ID and the name and main category like that, the data is there. Okay. Now I am here, whatever the data it is there in branch, I am reading it to the silver. So silver, so before coming to here, so what are the columns in the branch table? So those columns you can choose, and you can provide as a alias name. Instead of here C0, you can provide as a product ID, the name as a product name, main category, subcategory, and like that. And also regex as like SQL. Like you can cast that what is it?
Double, so decimal values.
Yeah, decimal values and double and cast it into the actual price and discount price. So
you're
if you want, you can
actually
see the
removing the $sign and whatever other characters, just leaving the decimal values there. Number and decimal.
Yeah. So then if you want, you can see the data, how it is there. Okay, now in you have to write so whatever the data in silver reading to the silver in the silver stage. So you can filter that as per the use case. You can filter. So read as like where clause in SQL. You can read means the ratings is not null and discount price is not null and the actual price is not null and rating is greater than 3. That is the filter I took it and so. This is the data after filter. I'm not sure is it work or not if I execute this command. How
That's
many
fine. Yeah,
records?
you go ahead. Just
Yeah, because my compute is another compute is there.
okay.
Actually, after filter, it will before it was 1 million above records. Now it is going to 150,000 records. I feel. I remember when I executed. Coming to here. Now what are the data in the silver? So now I am writing it to the in same like how it is in the bronze. So same thing, data silver, right? Format, data format, and save as a silver table. So 150,000 records stored in here. Like once you get it, uh, uh, yeah. So here it is showing the 5,000 for
Plus, yeah, that's
yeah,
fine. Yeah,
yeah,
more records are there.
yeah. So coming to in the gold layer, so we are aggregating. So as a like a scale aggregation like count, max, minimum, same commands. So you can for category, I'm using the count and subcategory and the average discount. So in the discount, I'm using the based on the column, main category and subcategory and uh, average discount. Okay, that is I did it group by here. So okay, and finally I wrote like 3 different uh, gold the data
Tables.
format.
Yeah.
Yeah, so tables like one is uh, category table, another is subcategory table, and another is subcategory average
Average
discount.
discount.
This is the yeah,
Wow.
yeah, that's it.
Yeah, that's very good, Subbu. Thank you so much. It's more like a refresher for us what we have done earlier with the use case, but thank you so much. Appreciate it. Good job. I know this is your first demo and you are new to the Databricks ecosystem and the Spark ecosystem. Good job. Yeah, you have done very
Actually,
good.
I
Explaining
want
it.
to go through the like features like asset transaction, match capacity,
Yeah,
and the
sure.
CSV type. But I did not practice. So next
No,
time
that's fine. Yeah,
I
you've done
will
a
give
good
it
job. Good
yeah
job.
feature check.
Guys, team, please, your comments, feedback. Yeah.
Is this the first time you developed in Databricks? Subbu, right?
Yes.
Yeah, this is the
Oh,
first time.
wow.
Yeah,
Oh,
first time.
that's awesome. That's awesome, actually. Yeah. It's just, I think you covered everything, whatever you learned in the classes.
Yeah,
Good to see.
it's more
Yeah.
like a refresh. Thank you, Prasanna. Yeah, thank you, guys.
Thank you.
Yeah, okay. So we have some more time. So I want to talk about the use case. So I have something that we did already, the JSON format earlier. So recently we've got like support for the variant data type. So I just want to explore a little bit on the variant data type and show you. It's more like, last time we did reading the JSON and go through it. But before that, I just want to talk about what we are doing, the use case. So let me first go through this and see. Then we can talk about it if time permits. Let me share my screen. Okay. So in the recent Databricks summit, you must have seen, right, that they have introduced the variant data type, and now it is generally available. I was trying to do some kind of exploration with that. I found it with the SQL support for the variant data type, but not yet on the Python PySpark data type. So I'm still exploring on that. But for now, I will just go through what we did with the variant data type. The first thing what I did was when you go to compute, so when we normally create the compute, so the variant data type is available on the 15 plus, the runtime, Databricks runtime 15 plus. So I just used the compute when I created. I used 15.3 beta. Are you guys still able to hear me?
Yes.
Yeah.
We can hear you.
Okay. 15.3 beta, so that we have that variant data type support here. And then I used the simple JSON file, what we have done earlier. This age, city, and name JSON file. I think we should have it here if I can show. Yeah, so this is the JSON file we have used earlier to read. But when we read directly as a JSON file, and then it would directly show us the, it kind of read the schema, and then we can also provide the schema and then it give into the column names. For the variant data type, what I did was I'm reading it as a text file, okay, not as a JSON file. So why I did was I just wanted to prep the data and have it in a different table so that I can later use it in a view. So I just read it in the text, but later when we have the variant data type, maybe we can directly read it as JSON and put it in the variant column. But for now, just for this experiment, for this exploration, I just read it as text file and then display. So when I read it as text file, it will all come as just the column called value. So everything is there in just one column. It's just a string column. Okay. If you look at this, value is string here. Now, if you go here, last time when we read, it is already read into different, split into different attributes, different columns with its data types. Correct. So now we only have this string column, which is called value. And I created a temporary view called JSON raw view on that data frame. So next, what I'm doing is going into SQL, and then there is a function called parse JSON value. So value is this column. So I'm taking this column from this view and applying the parse JSON function, which will actually can be stored as a variant data type. So when I do parse JSON, so this is a JSON representation of the string. Now I'm creating a table using variant. So this is what we wanted to try. So this is all just like prerequisite of preparation for us, just to put into the variant table as a variant data type. So I'm creating a table as select value from this JSON raw table, which is a string, and using parse JSON function in the SQL. Okay, so this when I do, so I get this, created this table, and then now I can read from the table this field as JSON var. So if you see here, the JSON var column is a data type is variant, right? So when you do parse JSON, it returns a data type of variant. So when the table is created with the data type variant. Now this is my final table, JSON variant table with a variant data type column. Now how do I read data from this? Is there's a new notation to read data from this table. We can just put it here and start reading this. So guys, don't get confused. This is advanced topic. We are just discussing here. Just to know that, okay, there is a new feature called variant to store the JSON representation, which is much faster than reading as a JSON file, splitting it into strings using schema and passing the entire JSON ourselves. So now I can select this column, this var colon attribute name colon age colon city from this table. So you can get, oh, what happened? Cannot be found. Let me do this. Oh. Something happening here. Let me redo this. Okay, so now it's the same. So kind of understand we came a roundabout and came back to the same output what we did here with JSON, the same thing, but using variant and the dot notation. So at the lowest level, it is simpler to do the JSON way for simple files here. But when you get more nested JSON, like we have seen the other day, parsing is more difficult. Putting a schema for something like this, and in the actual industry, there will be much more complexity, much more nesting within this JSON files. So when we have such files, it will be easier to use the variant data type. Okay, so let's see here. I also have a nested simple JSON file. I did this. So I'm reading the nested JSON file, which nested in the sense I have ID, name, and then I have attributes again as a JSON representation. So how do I read this? So I get the representation here, and then let me do table 2. So I'm creating a new nested variant table from this view. And here I'm accessing the data from this table. So here I'm accessing name and attributes. So attributes is again a complete JSON structure, which has weight, eye color, and height, right? So if I want to get other attributes from within this, I want to see eye color and hair color, I can just add dot notation here and ask for eye color. Okay, so JSON var colon attributes dot eye color. Or you can check for, let's say, height. Colon height from this. So height is there. For the second record, the height attribute is not there. So it will just return null. So if you look at here, the second record, height and weight are not there. So it will just return the null. So similar like this, you can go on, exploding this. So there is a article for this here, variant data type based on the nesting. So you have how you can, so raw store dot by skill, like what we did, it will give you the JSON, or you can also use braces notation to read from the variant. Or so you can also use array notation if you have multiple values within that. You can also flatten the rows into multiple rows using lateral. So you can just go through good reading, and not mandatory, not required as of now, but just a good reading part. Okay. Are you guys with me?
Yeah.
Yeah.
Okay. 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 Let me stop share here. So yeah, I think that's that we covered most of it, and what is required for the actual industry use cases and the at workplace, what we need to do. And most of our team is already done the certifications, and the rest of them are getting ready. Please do that. And after that, we will also look at doing the professional certification as well. Once you're comfortable with the associate and then have more practice. Okay. I want to talk about the use case where we have another like 10 minutes. So we want to talk about the use case, what we are doing at a workplace, but I would like to talk about it later. So if you have any questions till now, before we stop the recording, and then we can continue the discussion.
Arun, can you talk about executor memory? One of the optimization techniques that Amulya presented.
Optimization techniques in the executor memory.
Yeah, it says something like executor memory and also the broadcast join. We know about broadcast join, but I'm wondering what is the executor?
Okay.
I think, sorry.
Yeah, go ahead, Amulya.
I think it's the executor memory. We will be defining it at the time of giving the Spark submit command. It's the memory which we have to calculate based upon our data size that we process.
Right.
Like what is the correlation?
Yeah. So let me take that. 1 second. 1 second. Okay. See, what Amulya is doing is kind of using PySpark, right? So when you use PySpark, your cluster is custom. It's not a Databricks cluster. So you're creating your own cluster, or you already have a cluster that you're going to use, and you're submitting your job to the cluster, the Spark job. And when you're submitting the Spark job, remember we kind of talked about the joins and the shuffle, right? And the data skew. So what is data skew? When some of the worker nodes has more data to process than the other nodes. Or at that point, let's say I have 100 GB of data, my data frame, and then I'm joining another 100 GB of data. And one, based on the keys, let's say one node gets 30 GB of data, and my node executor has only 20 GB. So what happens? It will start, shuffling or spilling the data to the disk. But if it doesn't fit in the memory of the entire executor, it's not even within the executor memory. So you get out of memory errors, right? When you want to fit everything, cache it, and if there is no memory in that, so it will spill the it'll throw out of memory error, right? So when you're designing, when you're using the cluster, you have to make sure all your data processing is first. How do you make sure that it's evenly distributed? That is, make sure you don't have the data skew, and your data fits into the memory of the executor. So you have to design your data, what you're using in memory, or you're writing to the disk. Based on that, you have to, when you're caching, right? So caching, it should fit in the memory. Or when you are broadcasting a table, we talked about broadcast join, right? So you're broadcasting a table, and then if your memory is only 1 GB and you're broadcasting a 2 GB table to that, so it will not fit in the memory, right? So it will throw out of memory. So that's how you have to check what memory you have on each of executor and how much data you are storing on those executors, on those nodes. So that is the executor memory that you have to manage when you are doing the cluster. So how many executors I have, how much data I am processing, what kind of joins I am doing, is there a data skew? So all of that you have to manage. Now, in the context of Databricks clusters, so we have two options. One is scale up. So it will automatically scale if that memory is not sufficient. It will automatically scale, add more executors or add more machines, so it gets distributed. The second option we are going to get, just going into the new era, is serverless, where, as Srini has also published the document a few days ago, all of this complexity is going away. So you don't even need to worry about executors, workers, cluster, or everything is managed for you. So we don't have to. So we are getting there. We are evolving. As DK has also mentioned, that all of these complexities are going away as you're using modern architecture and modern tools that Databricks is providing, right? So this is a perfect example of how, when you use raw Spark, just the engine, you have to take care of all the nitty-gritties, all the cluster size, memory, data, and all of that. But when you're using the latest tools developments like Databricks, if you go serverless, you don't even have to worry about how much is executor memory, how many machines I have. And even now you have the scaling. You can say auto scale up to 10 machines based on my performance and data, right? So that is, most of that complexity is being handled by the systems. Does that answer your question?
Thanks, Harun. Like even now, if we are not considering serverless, how do I know what the executor memory is?
So executor memory, see here, when you do your cluster, right? The cluster has memory. So this is you have driver type. So this is the executor, 15.3 GB, 2 cores, right? So you have all of that in the memory here. So this is the master. You can go and see in the environment and the executors.
Oh, got it.
Yeah, so all of this is there. You can go and see how much is my executor memory, how much is storage memory. It's 4 GB on this. So disk is not used. So it has 8 cores. So I'm using only one machine. So it has 8 cores and 4 GB memory. So active RDD block. So all of this is there. You can go and see what is the memory and all of that in here.
Okay, thanks.
The executor ID. Yeah. Okay. Yeah. Any other questions? So executor memory and another thing that you talked about, right?
Broadcast join. I think we understand what the broadcast.
Oh, okay. Yeah. Oh, okay. So broadcast join we talked about. I think Amulya put a point called broadcast variable, right? So broadcast variable is It's the same thing, right? So it's not a data table, but it's a variable. So let's say you're writing loops in normal programming language. So you want to send that value to each of the function that is processing. So you can broadcast, you can publish that variable to all the nodes if they want to use. Okay. Same thing, another concept is accumulator. Accumulator is like read only. It's just a counter. If you want to see count of records on each of the nodes, so use accumulator at the driver level. But if you want to publish it to the nodes to read, then it is broadcast. So accumulators and broadcast variables you use in the distributed computing, because all your program is not running on one machine. So let's say I have 100 records on 3 nodes, right? So when I say count, what is the count? On which machine, right? It's not on one drive. So 100 records are on one machine, 50 records on another machine. So how do I know what is the count? So that is the accumulator. So each node will be updating that count, and then all other nodes will also be updating that together. So when you return it to the driver, you get some count of all the records from all the machines. So that is how you use the accumulator, so that it gets updated from all the individual machines, not just one machine. And broadcast is the other way. You publish from one machine, driver machine, to all the nodes, kind of.
A good point, Harun. Let me add a couple of.
Sure.
So
Sure.
to highlight again, everyone, accumulator. See, accumulator is a variable, as Harun mentioned. Say you want to count what is going on, the total count on 10 machines, your programs are running. You know, general loop, x is equal to x plus 1, something like that you put, right? To increase the counter, Purnima, right? Say one machine, it is increasing. Anything you are counting, see, not the number of rows in a table, some variables you want to count. So what happens is, in one machine, you get the count as some 10. In another machine, you got as 11. Another machine, you got as a 20. So your function only does the count on distributed worker, but how you aggregate them together. So that is where as Harun is saying, accumulator is a variable which will be keep tracking of all the things. So it does individual counts and finally accumulates. That's why the word accumulates. It accumulates and it sums up all these loops of all these machines and gives you the counter. Suppose you are logging something. I don't have right use cases, but theoretically, also maybe Harun, let's share some example in the group, some sample codes. So accumulator is basically, as Harun mentioned, a aggregated accumulator, which used for count, number one. The broadcast, as Harun has mentioned, again. So Purnima and everyone, see, again, you are doing this. We are talking about a distributed computing. For general computing, any variable is available anywhere. Suppose even you want to do a join, like broadcast join, that came from them, that only. See, suppose you don't have what you called, say locations. Say you have a location code, location description is available in a small data set. Suppose you want to join what you call your main table, which is available in the in the distributed computing in the worker machine. Purnima, imagine that scenario. Main table, millions of rows of the tables are there, which has a location code, but you want a location description. So location description if you location description is there available in a dimension table, like a location underscore TBL. So what happens, Purnima, if you take table 1, which is a million rows, table 2, which is location table, small table. If you just read them as a data frame, if you try to join, what happens? It's a shuffle, right? It's a shuffle, correct? You have data frame 1, data frame 2, data frame 1 is distributed, data frame 2 is distributed, and you are trying to join them. It's a big shuffle, correct, Purnima? Can you imagine that scenario first?
Yes, yeah, yes.
Yeah. So if it is really needed, if these two are big tables, that makes sense. The shuffle is okay. But for every small table also, if you are doing a shuffle, it becomes a problem. So then what happens is you take this small data set, the location descriptions, maybe your company may have 1,000 locations or 10,000 locations. Still, it is a small table, right? 10,000 rows. What is a big deal, Purnima? Correct? It's not a big table, right? 10,000 rows, you read as a data frame, but you keep it as a variable. You broadcast it to all the machines. Then what happens in each mission? This location description table is available in each mission. The full table is available, not as a distributed. So if you have 10 machines, in each 10 machines, that location description table is available when you broadcast it. You're broadcasting to all the 10 machines. It means when the join is happening, Purnima, Chandra, then what happens? It is not a shuffle. At least that join is not shuffle, because the location description full table is available in each mission. But how you got the location description as a full table? Because you broadcasted it. You broadcasted it. Can you imagine that scenario, Purnima, Chandra?
Yeah, it makes sense.
Yeah, when you broadcast it, it doesn't distribute. In fact, what I mean, it doesn't create partitions for that. The whole table is available to all the machines. When the whole table is available, which are small tables, like 500 MB or 250 MB, you can use that whole table to join to another bigger billions of rows of the tables. The big table anyway has to be distributed in multiple machines as a partitions. But the joining it also, if you distribute it, what happens is you're mixing many things. The shuffle becomes complex. At least one variable is fully available. One that location descriptions. Your company has 10,000 locations. That is available there in each mission is a full table available. Since one table is fully available, another table is a distributed, which has a partitions. You can join whatever the join that is happening. It will happen fast. So in first mission, some join happens. One is full table, another is a distributed table. In second mission, one is full table, another is distributed. Some join happens. Another mission like that in 10, it happens. At least you could able to nail down one table easily because its size is not too big. So you use the broadcast variable. So you read a data frame and keep it in the broadcast variable and you broadcast it. So then you can do the broadcast join with that. So that's the theory. Harun or I will look into some example code and share it to you. Any question on that, Purnima? Does it make at least little sense?
It makes sense, Srini. Yes.
Okay. Because it's a distributed. Only interestingly, in the whole Spark ecosystem, there are only two variables, which is accumulator and broadcast variables. These are only used. Rest all data frames, all distributed, your custom variables. These two variables are created for a reason. Accumulator is to found the counters accumulating. You want to count something. Even if you do even rows count also, each machine will have its own count, right? Because your data frame is distributed. If you count in one mission, you'll get 1 million rows. In another mission, you may get 1.5 million, another. But somewhere there should be a mechanism to accumulate all of them, right? Otherwise, the counter is not correct. That's why accumulator is used. Broadcast is also your driver machine. You know how the Spark works. Spark code is initiated by the driver machine. And it is the one which sends the instructions to all the machines to execute. So when it is sending the instructions, when it is sending all the Spark code, it sends this broadcast variable. It can be general variable, but mostly it will be data sets, data frames. You send that, then do the broadcast join. So to do the broadcast join, you need to broadcast first with the broadcast variable. DK, does it make sense? Chandra, Kishore, Subbu?
Yeah, it makes perfect sense. Yeah.
Yes, Srini, yeah.
Super. I think anything else remaining, Harun? For today, I think we are done. It's 11:05. Any questions?
Yeah, we are good, Srini.
Any questions, guys? Awesome. Then I encourage everyone to revise this one, take a couple of weeks and post questions in the group. Try to write the exam, connect